Hello, everybody. We have 2.5 hours together this evening on the neuroscience of creativity. And I have to say, I am extremely happy to be presenting this because it's been such a joy both to create this seminar and to be able to express myself a bit creatively in the collation of all the materials. In the presentation, there are going to be interactive parts, and paper and pen will be useful if you want to play along with those. So here we go. We have got 5 parts to the presentation today. We will be having a break at some point towards the middle. I don't know exactly when because it depends how fast we get through the material, but there will be a 4 or 5 minute break at some point just to refresh ourselves. It will likely happen somewhere in between the third and fourth parts, but let's see. So we are going to start with the neurobiology and the current neuroscience theory behind creativity. And I've called that part Networks and Nerds. Here on the screen, I've made that appear on the brainstem area because that's the very basis that we need to understand all of the rest. And once we've looked at that, which is more neuroscientific and neuroanatomical, we're going to go into what happens in people who have brain damage, specifically brain damage from neurodegenerative disease. And it's always very interesting to learn from people whose brains have got some kind of dysfunction so that we can understand what the function would normally be or how it's disturbed through that dysfunction. So I've got quite a big section on that with lots of artwork to show you from artists with different forms of neurodegenerative disease. Then we'll go into creativity theory. So we're going to apply what we learn about networks and nerds to the ideas about creative frameworks that have been identified by researchers. Then we'll go into idea creativity. So while I can't teach you to become fantastic painters if you aren't already one, or fantastic photographers or musicians or whatever it may be, I can share with you approaches to increasing your creativity for ideas, which is different to craftsmanship. It's more of a kind of mental practice, idea craftsmanship, if you like. So that will be very interactive. There will be lots of things for us to do there together. And then finally, at the end, as we get to the frontal cortex part of this brain, we have a surprise. So that's, of course, something you'll need to wait for, which is a part of the frontal cortex function to keep ourselves willing and focused while we're waiting for something to happen at the end. So there we go. Let's get started then. So I think it would be fair to say that creativity is complex. And if you've come here to this seminar expecting a very easy explanation of exactly how creativity works in the brain with all the biological breakdown, you may find yourself a bit disappointed. We do have neuroanatomy and neuropsychology as we go along, but the fact of the matter is that neuroscience research hasn't really coined it 100% yet. So what I'm going to be presenting to you are the current theories that have the most credibility, and I've picked 2 that I find are particularly coherent. So sometimes science comes up with wildly different explanations for various phenomena, and it can be quite difficult to digest that because there doesn't seem to be overlap. But what I'm going to be talking about today, what is happening in the brain when we engage in creative thinking, is going to be an explanation on the level of 2 different levels of anatomy in the brain. We're going to be talking about neural networks and what are called nerds. Okay, you'll learn more about what that means as we go along. So let's go into neural networks to begin with. As we are sitting here right now, looking at the picture on the screen and listening to my voice saying neural networks, there are a whole lot of things happening in the brain that we are not completely aware of and that we're also not controlling. And that's necessary because otherwise, imagine that you had to remember every single time you had to breathe, or every single time you had to blink, or you had to remember how to decode every line on the screen to make that into a letter and make that into a word and make that word into meaning for yourself. So those are just tiny examples of the amount of things that are going on in your brain at your service right now. The better we get at something, for example, reading, the more we master that ability, the more we have white matter connections in those networks. And that creates something called automaticity. So, for example, when you learn to drive, everything seems incredibly complicated to begin with. So many things to think about, so many things that could go wrong. But when you master that after your first 5,000 kilometers or so, then there is a way in which the brain can almost drive for you on autopilot while you can engage in thinking, listening to music, talking to someone in the car, all things that would have been unimaginable when you first started learning the skill. And what actually happens in the brain is that there are constantly automatic, previously learned programs that are nominating themselves to be picked. So as I'm sitting here right now, I'm staying relatively calm on my seat, but I have a habit of expressing myself with my hands, and I'm not consciously doing that. So there are various programs in my motor cortex that are nominating themselves for me to make these sorts of movements as I'm trying to bring emphasis to something subconsciously. So you could say in a way that there are lots of very eager little programs running in the brain at the same time, and the one that is most keen gets nominated for the next movement or action that we make, even for the next place our thoughts go to. And you can see that, for example, when people are playing instruments in an improvised way. So they're not reading the music, but they're just allowing the next thing to come. The same with driving, weaving your way through traffic. You don't know necessarily what's happening a kilometer down the road, but just responding. And if there's suddenly an emergency, you have different programs, hopefully, that will spring into action and do the right thing for you. Gymnastics, singing, writing, sculpting, even parenting. Those sorts of movements that one needs to make in order to soothe a child, or the right way to pick up a baby. I'm speaking from very present experience at the moment. So those are all examples of automaticity that we build in the brain. And neural networks are built on automaticity. The white matter that myelinates the connections between the neurons are what create very fast responses to situations for us without having to consciously think. And I put a little note on here that this also applies to therapy and healing skills for those of you who are in those domains. We start out unconsciously ignorant, i.e. we don't know what we don't know, and we move towards conscious ignorance. So this is like, again, learning to drive the car. We become aware of how difficult that seems and how other people can do it, and we have such a long way to go to become masterful. And then we move towards conscious mastery. So at this point, we've started to myelinate those white matter connections, and things are happening more quickly for us, but we're still aware of having to make an effort to focus and concentrate. And then finally, if we're lucky enough, we get to unconscious mastery. So at this point, we have fully automatic neural networks that are doing whatever the task is at hand. And you might find examples of that from your own life. If some of you are touch typists, you'll be able to not even look at the keyboard. You could probably take notes without even thinking about what you're doing, just transcribing my voice as we're going along. So that's neural networks. Now let's hone in a little bit on the ones that are of specific interest to us today. So we're going to be looking at three networks of interest to creativity, which is the default mode network, the executive control network, and the salience network. And we'll look at them in that order. So here we go. The default mode network. On the image here on the screen, you can see a scan of the brain, which is showing you where activations happen when the default mode network is triggered. So it's located in a couple of places in the brain, and you just need to imagine that there are long connections that are joining those places and the neurons within those places. So it's in the ventromedial prefrontal cortex and in the inferior parietal lobule, and what's called the precuneus, which is this place here in between the two hemispheres at the back. So there's a sulcus that goes down that separates the two hemispheres here, and the precuneus is what is located on either side as you go down. And the default mode network has shown to be active when we're not thinking of doing anything, or when we're supposedly at rest. So this is interesting. When we're not consciously engaging ourselves with something, this network activates. So that's just a reminder for you that the brain never rests, except if we're in a deep state of coma or indeed dead. Otherwise, there is always something going on. So what has been shown by different studies doing functional MRI scans is that this network is associated with internally directive generative thought, which means that we are contemplating the past and the future. So we're not in the now when this network is active. Our mind might be wandering, daydreaming. We might be imagining things from other perspectives, other people's perspectives, and we might be simulating different outcomes from a situation. We might even be ruminating on conversations that we've had or things that happened to us and going over them again in our mind. So going into this default mode network is a way of not being fully focused on the present moment, but instead allowing for other associations from our memory or our simulation of the future to come to us. And that has been shown to be an essential part of allowing ideas to come, which we'll see when we talk about people with neurodegenerative disease that has a significant effect on this default mode network. So just remember, default mode network is a place where we retreat from the world. You could say we contract into ourselves, and from there begin to connect other things, time traveling backwards and forwards in our lives, imagining, simulating, taking other perspectives. Default mode network. So if at any point you have questions about any of this or insights that come to you, you're very welcome to share them, and I will just answer as we go along where possible. One little interesting fact about the default mode network is that a study was done where they read out fairy tales to people in different languages. So there would be people speaking, for example, 5 different languages to people who also spoke those languages, of course. So there would be an English fairy tale being told to English people, a Danish one to Danish people, a Dutch one to Dutch people, and so forth. And they were scanning the brains of the people listening to the fairy tales at the same time. And they found that no matter what the language was that was being spoken, people were activating the default mode network at approximately the same places in the story. So, for example, were it Little Red Riding Hood that we were listening to, Little Red Riding Hood went into the forest to pick some berries. And then no matter what the language was that was spoken in, everybody went into the default mode network activation to process this Little Red Riding Hood forest and berry picking scenario. And then the next bit of the story would come, and after that, everyone in the default mode network again. So there is something about it that allows us to take in what we're perceiving and experiencing, pause, and become a little bit vague, perhaps. This is the mode we're in when people are talking to us, but we're not really there. And we say, oh, sorry, I zoned out. That's the default network that you emigrated to temporarily. Okay, so this stands in stark contrast to the next network that we're going to be talking about, which is the executive control network. So this one is all about the present moment. So the executive control network is highly present in the lateral prefrontal cortex. So you remember the default mode network was more in the ventromedial prefrontal cortex down here inside this sulcus. So this one is in the lateral prefrontal cortex that it's majorly activated. And when we activate that one, we are externally directing our attention. So we are taking in actively information from the outside world, keeping it in our working memory, deciding what response we're going to have, inhibiting inappropriate responses. We're switching between different tasks. Those of you who've been to some of these previous neuroscience seminars with me will know all about that. And we're also going into problem-solving mode. So we're using information that's coming at us to do something in the moment to create an output. So it's also something that allows us to give attention to ideas while inhibiting irrelevant information to come to us. So if you imagine that you are in your default mode network and you get an idea about something that comes forward, in order to do something useful with that idea, you might also have to stop freely daydreaming to actually implement some of it. And we're going to hear a lot about that as we start going into more detail about the networks and the nodes. So just noticing a couple of comments here from the chat. No wonder meditating is so challenging. That involves the default mode network, but also the conscious control from the executive control network to try and keep us on track. The default mode network activates as soon as we're not doing anything. And if we're used to thinking we're not doing anything when we sit in a meditative position, of course, we're going to start ruminating and taking other perspectives. So yes, meditation does require a mental discipline that brings us more into a position of executive control to begin with, and in a way overriding the default mode network that otherwise just starts loosely dissociating before we even realize we've gone. And then another question about at what age is the default mode network formed and can it change? So the neocortex is in evolution throughout infancy, childhood, the adolescent years. The prefrontal cortex doesn't actually ever really fully finish forming, but you could say it reaches a certain stage of maturity in its development in our early 20s. And the default mode network is part of the parietal lobe, as we saw before, and part of the prefrontal cortex. So you could say that the default mode network isn't really fully formed until the prefrontal cortex is fully formed. But the parietal lobe does finish forming a lot earlier than that. The parietal lobe is where we are receiving sensory information from our bodies. Now, those of you who have young children may realize that there is quite a large age range where they're not able to specifically pinpoint sensations in the body. So kids who are, I think it's until about the age of 7, they'll say, I have a tummy ache. And actually that means that something could be wrong in their body anywhere pretty much from the chest down to the knees. And they don't have the ability to pinpoint it quite as precisely as they do later on as the brain continues forming. So you could say that one part of the default mode network would begin to mature as we reach the age of 6, 7 and thereabouts. But the prefrontal cortex part doesn't actually mature fully until our early 20s. So, of course, kids can go into a daydream, but this idea of taking perspective is also called theory of mind in psychology. That's something that really it develops in specific stages that you can measure by asking children to take others' perspectives and what information they can give you about what another person is thinking. But that could get into a very long discussion, which is very interesting, but you might just want to look up something like theory of mind and development through ages to get more information on that. So there we have the executive control network, and that's certainly also something that doesn't develop fully until we are in our early 20s, where we can really begin to work fluently with directing our attention, switching between tasks, problem solving, inhibiting emotional responses as well. So we're going to move to the third network now, which is the salience network. So those of you who speak some Roman-based languages might be aware of the word root of salience. It comes from the Latin salience, which means to leap. So a salient idea is one that jumps out. And in the brain, it involves very much the hippocampus, which is shown here in the diagram as the kind of little white curly thing. Don't mistake it for the ear, that's the blue thing here. But it's in the temporal lobe and called hippocampus because when you dissect it, it looks a little bit like a seahorse. And hippocampus is Latin for seahorse. So the salience network involves hippocampus, which is related to memory, and the entorhinal cortex, which is associated just laterally to it. And that is the gateway to the hippocampus, if you like. So what the salience network is doing is it's constantly monitoring all of this automaticity that we spoke about earlier that's going on in the brain, and it's selecting for us the input that's leaping the highest, the one that has most charge behind it. So you could say that the salience network is in fact monitoring input. The brain is constantly processing input from the outside world and prioritizing it. And here's the bit that involves the hippocampus. It's prioritizing it based on memories of previous experience. Otherwise, how would we know what to pay attention to? Does a red light on the road mean more than, for example, a person behind us honking their horn wanting us to move along? And then we might then remember that running a red light just because somebody behind us is speeding us along is a really bad idea because it could cause accidents, we could get a fine, and giving our power away to people honking behind us might not be good for our personal assertiveness anyway. So the hippocampus holds information stored from the past and helps us subconsciously monitor what's coming in to find out what we should give most attention to, and then hopefully allows us to process all of this information that's happening efficiently. It's also, just anecdotally, what will make your ears tweak if you are having a conversation with someone and then somebody nearby is having a conversation with somebody else and your name is mentioned. Your salience network will be monitoring that for you without you even realizing, and at the mention of your name, I don't know if it's just me who gets that, but I quite physically feel my ear tweaking, and then I start to pay a bit of a dual attention to what's going on in front of me and over there, wherever my name was mentioned. So that's salience at play right there. So a question here about, does hippocampus also code memory? Indeed it does. It's one of two major memory encoding centers in the brain. The other one is the amygdala. So the hippocampus tends to code memory that's more declarative about facts. Paris is the capital of France. I went there and had my breakfast, and then I did this and I did that. Episodic memory. Whereas the amygdala encodes memory that has more of an emotional feel to it. So if there's something that really scares us, it's very useful for our own physical survival and evolution of a species to remember it. So we don't need to be exposed to a stinging wasp 10 times before remembering wasps stay away or avoid getting stung by them. That might only need to happen once before that memory comes in. So the amygdala, you could say, adds a kind of tone to memories as they're coming in. And then the hippocampus is doing the encoding of the more fact-based matter. But please don't think that every single memory is then stored in the hippocampus, because even when people have serious damage to their hippocampus on both sides of the brain, they still have access to old memories, long-term memories. So studies have shown that after about 24 hours, memories that have gone into the hippocampus start to disseminate through the cortex and in fact get distributed across the brain. And as we start talking more about neural networks in detail and these nerds soon, you'll get an idea of how that works. So another comment here about how kids are aware of spirit world naturally until the age of 7, and then they need to live in a place of encouragement, or they lose the naturalness of it. Yeah, so that's to do with the development of the brain, the comment I was making earlier, I guess, how there are things that are natural until a certain age, and then as more reason sets in and inhibition sets in from the frontal cortex, we start to think differently. We're going to see more about that when we talk about creativity as well, from the perspective of theories and development of the brain. So those are the three networks. We talked about the default mode network, the executive control network, and the salience network. Now, what's actually happening in the brain is that those networks are in a state of interplay. And in what you might call normal people, if you've met lots of those, the salience network tends to suppress either the executive control network or the default mode network at any one time. And if you consider it, it sort of makes sense, because we need the network activated that's best at dealing with the situation that we're in. So if we're driving, it's probably a good idea to at least occasionally pay attention to the road, or at least for the salience network to bring our full attention to the road if somebody suddenly slams on their brakes in front of us or somebody steps out in front of us. Then we need to be in the executive control network to quickly decide what to do, make a plan, etc. Whereas if you're on a long, empty motorway somewhere and there's nothing going on really, you might find yourself going into the default mode network as the brain is making use of that time and space to process some thoughts and ideas, take perspectives about what you might do the next day or when you get home, etc. So it is a normal function to be in one or the other, depending on the situation, the context you're in. However, in highly creative people, that mutual suppression does not fully occur. So you can have key parts of the problem solving and internal rumination systems simultaneously engaged. And what that then does is it allows for creative connections to be made on an ongoing basis as the default mode network is connecting things, ruminating, perspective taking, dealing with the before and the after. and the executive control network is paying attention to those, picking out things and allowing for more durable connections to be made as we're trying to figure out how to apply it. So we're going to go into more detail about that now as we get onto the next part of the biological explanation for creativity, which is these things called nerds. So before we can fully go into the nerds, I need to share a bit more information with you about how neurons respond in the brain. So just remember, the networks are across the brain. It's a part of gross anatomy in the brain, but if you do a brain dissection, you can see the networks. You can see the white matter connecting parts of the brain that are wide apart. Nerds are on a smaller level. They're composed of banks of neurons. So I'll tell you a little bit about how neurons respond to stimuli so you'll get a sense of these nerds. So essentially, neurons in the brain are tuned to respond to specific ranges of micro features. There is no single neuron in your brain that holds the entire concept of your grandmother. And this example of grandmother gets used a lot in neuroscience because there was an idea originally that there was a grandmother neuron. And if you remove that neuron, you would no longer know about your grandmother or recognize her. But if we had to do that for every single concept, situation, every single angle of our grandmother's profile, we wouldn't have enough neurons in the brain, although there are 80 billion of them. So in a way, the brain is much more efficient than that. What it does instead is it has neurons that are particularly attuned to specific microfeatures. For example, what I wrote here, for example, an azure shade of blue, which is different to a turquoise shade of blue or even a royal shade of blue. And you can also have a neuron that is attuned to respond specifically to when you sense in somebody the quality of being shrewd, this kind of astuteness and good judgment that somebody who's shrewd might have. So there's a neuron that will respond specifically to that experience. And what the image here on the screen is showing you is the results from an experiment that was done on monkeys back in the mid-90s, where they were able to put some deep electrodes into a monkey's brain. Unfortunately, a lot of science is done doing that sort of intervention on animals still, but by the mid-90s, I guess there were protocols in place that meant that the animal had to be treated humanely, so there would have been some kind of way of alleviating the distress or the pain for the monkey, or so I really hope. So what we're seeing here from these measurements that the electrode took was what happened in terms of activation, which are the bars that are here horizontally, when the monkey was being shown specific shapes. And the shapes are these blobs that are above the activation sequences. So what they found was there was a particular neuron in the monkey's brain that activated really strongly when it saw this sort of shape. So a circle with a little blob sticking out of the top left corner. And when they showed the monkey that shape, that particular neuron had that activation form. However, when they showed the monkey just a circular shape, there was no activation in that particular neuron. And the same if they showed the other little blobby component part, no activation. If they showed the monkey the shape turned around 180 degrees, there was the tiniest of activation, but nothing like when the shape was shown the correct way around. The same if they showed the shape with a square protrusion instead of the red one, the tiniest activation. This is where it gets interesting. They then showed the monkey the shape with the bottom part missing, and it had a halfway activation in comparison to the original activation of 1.0. If they showed it the shape with a bigger and more specifically delineated blob on the end, you might see how that's different to the one that's the original one, that has more of a smooth curve. It had about a quarter of an activation of the original one. And if they showed it kind of even more merged together, so with less of a delineation between the two parts, smaller activation. No activation when they just showed the top half, the top right half, and a tiny activation when they showed the bottom left half. Interesting. If they then showed the circle with a tiny little blob sticking out, an even stronger activation than the original one. So that means that that neuron was actually more specifically tuned to this shape down here than the original one that they thought it was attuned to, right? And then finally, they showed it this sort of shape here with a very elongated little bit sticking out, which showed quite a strong activation, but not as strong as these other two here. So this is really to give you the idea that there are neurons in the brain that respond very strongly to a particular stimulus known as a microfeature. And the interesting thing is that the neuron will also respond to things that are sort of similar, but not quite as much. And neurons around this one will also respond a bit to the same stimulus, but not as strongly as that particular neuron. And what that essentially means is that as we are making memories, those items in our memory are being distributed across what's called cell assemblies, so collections of cells that contain many neurons. So there could, for example, be 100 neurons that are all responding somewhat to circles with bits sticking out of them. And in the same vein, every neuron is participating in the storage of many items. So when I said to you earlier that memories are moved from the hippocampus into a more wide distribution across the cortex, that's essentially what's happening, that there are neurons that respond to all sorts of different things. And when you put those together, you get the memory that you think you're accessing, that is your grandmother. But what you're effectively accessing is a reconstruction of something to do with the feeling you get from her, something to do with perhaps your grandmother's scent, something to do with the way her hair was, how she moved, how she spoke to you, the feeling of her touch. All of that gets reassembled from the different neurons that could actually be used to hold lots of different things. So for example, the way your grandmother moves, that particular type of movement might also be activated when you see somebody else walking in the street, and they will remind you of your grandmother. So it's the same cell that's activated, but it has different connections to other neurons that you're then traveling along, and that's how we have associated memories come up for us. So this is all on the way to building up to this idea of nerds. So we'll take the next step now as we get ready for the whole nerd phenomenon. So somebody's just asked in the chat whether this is projection. Well, projection is probably a little bit more complicated than that, but you could say that when we are reminded of somebody, there might be a certain amount of transference going on. So if I see somebody in the street who walks like my grandmother, I might start to act with her or feel towards her as though she were my grandmother. Projection would then be if I'm feeling something inside myself, for example, I really like when somebody stops the traffic for me, or a car stops because I need to pull out, and somebody then doesn't, and I consider that very rude. I will project onto somebody else that they're very rude, although they might not be rude at all if they don't stop the traffic or let me pull out. It could just be that they didn't see me, right? So if I'm taking something from inside me and putting it on another and saying that's how you are or what you're thinking, then I'm projecting. So you could say transference is involved in these network activations. So neuron activation is not all or nothing. There's another question here about what determines the level of activation. So this is something that's been a huge debate recently. It used to be that people used to think a neuron is either firing or it's not. But actually what's happening is lots of neurons are coming together to create a signal that is then sent on to other neurons. And depending on the strength of that collective signal, that next neuron may partially fire. What's actually been found recently is that the two sides of a neuron, as it comes down the axon and into the dendrites, can fire differentially. So it's not that one neuron can either fire or not. You could say that, yes, it takes a certain amount of signal strength for the signal to be collated and be passed down from the axon hillock down the axon itself. But there can be a weak signal that's passed down that's amplified and sent in one direction, and then a non-firing or very weak version is sent in another direction. So it used to be thought that firing was all or nothing, but actually it's turning out these days that there is more subtlety than that going on, particularly with this bilateral firing potential in the axons. So like I said before, the same neurons can get used and reused in different capacities. My grandmother's walking style might be another old lady's walking style. And this is a phenomenon called neural re-entrance. So the same neuron can be re-entered many times in our perception of the world. And just a bit more vocabulary here for you in terms of this neuroscience of particular neurons and their memory activations. Items are stored in overlapping regions when they're correlated. So that means, if you just imagine this, this library brain I've put over here, libraries are sorted by themes. So you'll have architecture in one place and zoology somewhere else. And memory in that way is also what's called content addressable. So it's almost like there is an address for different types of content within the brain. And that means that in a certain part of the brain, there is a systematic relationship between the kind of input that's coming in and then where it gets encoded. So, I'm making a parallel here, but all the zoology type material would be in one place, all the information you have about different animals. And then it might be that next to that, you have information about different kinds of fur patterns, which is then related to the next part in your library about different kind of textile patterns, which then relates to different kinds of vegetation and foliage and flower patterns. And then before you know it, you're off into color spectrum and hue and nuance. So things are stored in quite predictable places in the brain, which is also how they managed to locate that neuron in the monkey's brain that were responding to this visual stimulus of a shape outline that sits very close to the visual cortex, in fact, just above, next to the place where visual movement is analyzed, processed in the brain. So the result of this is that episodes are stored in memory and can be evoked by stimuli that are similar. Or if you like, we can use the word resonance or even context specific. So animals tend to stimulate a similar part in the brain, and then other information we hold about that animal, for example, the noise that it makes, will be made available from other parts that bring us together the full picture along with any experiences we might have had of that. Okay? So we're slowly building up towards this idea of nerds now. We're almost there now. So here we go. I'm going to show an actual diagram. It's not obviously a picture of the brain. The brain doesn't have a kind of grid pattern inside it. But this is to show you what it looks like when there is an activation of a neuron. So to make a generalization, we have two types of ways that we activate our brain when we're thinking. So this goes a little bit back to the neural networks we were talking about. You can be engaged in analytical thinking, which means that you're focusing on something. Think about the executive control network, and that is activating a specific area. So if you were going to meditate specifically on the nature of cat, you would be targeting a very specific area of your brain. And I didn't say loosely associating around the idea of cat, right, which could bring in all kinds of other things, cartoons, fur, stroking something, purring, purring is useful for healing bones, etc. Not that, but a specific meditation on the concept of cat. If you do that, there will be what's called a spiky activation in the area where you hold this concept of what catness is. And what that's being shown as here on the screen is a kind of white aura around this neuron here, where we hold the current stimulus that we're focusing on. So I'm not saying this neuron holds everything about a cat and everything you need to know about that, but what you understand as a feline nature, that could be there. Now, that's analytical thinking. Associative thinking on this next picture here on the right is a broader, flatter area of activation within the brain. So what happens when we have a more associative way of thinking is we're activating a wider area. So this bit here, this neuron that has feline cat nature in it, is activated, but now this neuron up here is also being activated. And that might be where we hold information about superheroes that dress up as animals. And what do you know? Between the two of those, Catwoman emerges, right? So that's associative thinking. And if we get even more flat in our activation, so the same amount of charge, but spread over a wider area, we can start to recruit even more neurons that hold different kinds of micro features. This is where we then start to get into a chain of thought that brings us to somewhere perhaps quite unexpected. And this is where we can now start to define what a nerd is. So in the first picture, we have one neuron that's being activated, and you can say that the one up here that holds information about superheroes that's dressed up as animals isn't really relevant. But a nerd is when we are including something inside of our thought that previously wasn't considered to be analytically relevant. So we'll see even more about that on the next slide. But I'll just give you a little bit more information about this now. So if we are somebody who notices things, and we memorize items in a lot of detail because we're interested in them, or we're just one of those people that sees things and later on is interested in telling others about them. So we're really memorizing, seeing the world with a lot of detail. That increases the potential for overlap within these neurons because we are encoding more information. So for example, if I'd never paid attention to the fact that Catwoman dresses like a cat, although the name sort of gives it away, I wouldn't have the association here. I wouldn't be able to make that between those two neurons because she wouldn't be accessible to me. I would only have Batman and nothing in here to do with Catwoman, right? And this is applicable to all sorts of things. If you're noticing the shades, the sounds, the smell, the taste, all sorts of things, your intuitive, emotional response to things, and you're encoding all of those, you will have the possibility of much more nerd access as you're widening your focus. And what that then does is when we want to engage in creative thinking, we have more routes that will take us through these neurons to get us to unexpected places. So just looking at a couple of questions here from the chat. So if people are categorized as remembering by either seeing, hearing, feeling, their life has created groups of neurons that are well trained to do that particular job. Yeah, you can say that there are people who will say, oh, I'm a really visual person. But that doesn't mean that they hold their entire memory of their life just with the visual sense, unless they really are disabled in the other senses and there's some kind of neurological problem. They will probably still also, if they can smell, be triggered by the smell of something, the smell of Christmas, the smell of a particular perfume of someone they like or really don't like, right? So it might be that there's a part of their brain that they tend to use a lot and they make very easy associations there. When they do associative thinking, it might be that that's a part of the brain that they're primarily using and they don't let that flat activation go into some of the neighboring areas that are to do with the other senses. But I wouldn't buy that from people when they say, oh, I'm only this or that. Because part of the brain, the rear part of the parietal cortex is what's called the somatosensory association area. And the sole job of that part of the brain is to associate information from different senses and put them together. So we know, for example, what a pencil feels like, more or less. We know how many sides it has, if it's one of these traditional six-sided pencils. We also know what to expect when we write or draw with it. We also know what happens if we apply force in the middle and go like that. So there's tactile information. There might also be smell information, wood and lead. There might even be taste information if you've ever licked a pencil to try and kind of make it work better. And there's the sight information of it. So all of that is stored together. It might be that some people are just more used to using a certain sense, perhaps because they're more tuned into it. And whether that's something that we are nurtured into or whether nature brings us is a whole other debate. So then there's another question about, does a semi-sleep state encourage associative thinking? Yes, it does, because the semi-sleep state is a state where we are in primarily an alpha wave frequency in significant parts of the brain, and associative thinking is slower. In fact, studies show that if we are in a beta wave activation in the frontal lobe, we're not going to be able to have this kind of broader, slower activation across wider areas, in contrast to when we're in an alpha wave. So this is the same thing for some people. If you go into the shower, you will go into sort of default mode inside, right, which is also the default mode network, and you will broaden and flatten your activation area and start to have brilliant ideas. Okay, so we now know a little bit more about what nerds are. So it's something that's next to the relevant thought that might not be considered if we were being analytical, but that starts to get recruited as we widen our thinking. And so now we get to this word called neural cliques. That's collections, assemblies of cells. So nerds are a type of neural clique, much smaller than the neural networks we were talking about earlier. Neural networks can span across the brain with lots of white matter between them. Nerds are really recruited on the fly, depending on where you are in the brain. So for example, I was using this idea of a feline detecting neuron, and that happens to have around it superheroes that dress as animals, and it might also have texture of fur nearby. So the nerds that are available to me there are completely different to the nerds that are available around my experience of naming colors, for example. So you get the idea of neurons are much more dynamic. Networks are more like fixed structures in the brain laid down with white matter myelination. And nerds respond to more general, atypical, and abstract concepts in a situation. So things that are not so specific, but wider and maybe something to do with it if one was being a little bit metaphorical or symbolic, perhaps. And they're able to draw in these more remote connections due to the broadness and flatness of the activation area. And I just gave some ideas here of nerds that I could come up with. For example, an anachronism. So if you're looking at a film and you're in this analytical mode of naming, the era that every single thing that you're seeing is from, you would only spot an anachronism if you also allow the awareness of temporal context to come in. So an anachronism is only identified really through thinking next to the thing that you're analyzing, or things that make up a line without being a line themselves. So that could, for example, be if you hold up a disc and you turn that sideways, that's not a line, but that makes a line from a certain perspective. Or indeed, if you were to look at the horizon, as we know, the Earth isn't flat, but it looks like a line. So we have somewhere neurons and nerds around them that are identifying this sense of what is similar to something else, but it's a little bit more elusive. Or I think I'm quoting a song here, things that make me go, ooh. It's also, you would need nerds to identify the thing around what you're thinking about to realize that it could be connected to another thing. So these nerds are activated in associative thought. I hope you're getting a sense of how this works now. So I am going to now read for you a little story of tracking the birth of a creative idea. So this is a little bit like a neuroscience bedtime story, except it talks about analytical and associative thinking. So here we go. So we have this story of a girl called Amy. And the situation that Amy finds herself in is that she's an art student and she wants more privacy in her bedroom. But the problem is that her landlord doesn't have very much money to sort out the curtain situation for her. And the only curtains that he is willing to get her on the strict budget are quite ugly and thick. So they would actually block out all of the light in her bedroom, which would give her privacy, but her plants would die. So she asks around for second-hand curtains, thinking that she can try to solve the problem through this kind of straightforward deductive process. Well, I'll just get some other curtains than the ones that my landlord is offering to me. So she's using analytical thinking here to analyze the problem, and then a tiny little bit of associative thinking going, well, what other sort of curtains can I get hold of based on the fact that he won't get them for me? So my method of acquisition isn't through the landlord, but through somebody else. So she now begins to have neural cliques that are encoding memories of various curtains activated. For example, she has neurons responding to attributes of desirable curtains like soft, or hanging on curtain hooks, or translucent, large, and colorful. All of those neurons are now being activated in her brain as she's asking around. But none of her friends can help, unfortunately. Poor Amy. So her inability to solve the problem rationally eventually leads to a spontaneous and subconscious defocusing of her attention. She enters into a properly associative mode of thought now, and her activation function becomes flat, such that the associative structures of her memories are more widely probed. She is experiencing activation of neurons that respond to attributes such as soft, that are irrelevant to her goals of obtaining privacy. So those are now decreasing. It's not really about the softness. What she needs is privacy. So she's now having activation of neurons that respond to attributes such as translucent. That would be relevant to keeping her plants and her happiness levels high. So goal-relevant nerds are now getting recruited, as her memory begins to respond to not just specific aspects of her situation, i.e. her need for curtains, but to abstract concepts of her situation, i.e. the need for privacy. So she's going below her immediate strategy into the deeper need. Amy starts considering not just different kinds of window coverings, such as curtains and blinds, but other attractive ways of covering the window that would allow light to come through. And because memory is content addressable, remember we learned about that, there is a systematic relationship between the content of an item and the location in memory that's activated, neural cliques that respond to translucent and colourful are now being activated in the context of needing to cover the window. And now she is having previously encoded memories of certain acrylic paints, being an artist herself, that might be opaque enough to provide privacy, yet also translucent enough to let in light. This activation is spreading from neural cliques that respond to translucent and colourful into neural cliques that respond to other aspects of these acrylic paints, causing her to consciously think of them in this new context, resulting in something that is a reconstructive interference of curtain and paint put together that's now given her the idea of curtain paint, the idea of using paint to accomplish the job of curtains. Now this has some attributes of curtains, for example, covering her windows, and some attributes of paint, i.e. it hardens when you apply it, and it has attributes that they both share that allowed for the association to be made, i.e. translucency. Since she is an artist, she could have first thought of the idea of placing a painting in front of the window, then realizing it wouldn't let in any light at all, and then subsequently realizing she could just paint directly on the window. She could have got to the same idea by going a different way through those neural cliques. Alternatively, it could have been the more general concept of window covering that could have been combined with paint that gave this new idea of window paint. In either case, the resulting concept combination is new for Amy, because this particular distributed set of neurons had never been activated together before as an ensemble. Having hit upon this idea of painting the window, she must determine if it will work in practice. And I would add, maybe she should check with her landlord before she paints the window. Although in the short run, a flat activation function is helpful for creativity, maintaining it wouldn't be practical because the relationship between one thought and the next may be remote. And that means that she would have a stream of thought that lacks continuity from here on. Access to obscure associations at this point might be a distraction if she just continues loosely associating around the idea of translucency and opacity and paint. Thus, she now enters a more analytic mode by de-recruiting the nerds. So at this point, she's narrowing the region of memory that's getting activated. Her thought becomes more logical in character because the activation function becomes spikier, therefore affording finer control. Think executive control network as well. Fewer locations are releasing their contents to participate in the formation of the next thought. Now, experimenting with different paints, colors, brush styles, Amy begins to find paints that lets in light while obscuring visibility. And once she knows that it will work, the actual painting of the window offers more room for creativity once again, and she returns to a more associative mode of thought of how she would like to express herself on the window. And so by shifting back and forth along the spectrum from associative to analytical thinking, the fruits of associative thought become ingredients for analytical thought, and vice versa. So there we have a little neuroscience tale of the birth of a creative idea. So just to sum up some of the main points for you now. Creativity involves not just the ability to defocus and freely associate, but also the ability to focus and concentrate. So to recap for you, associative thought considers items in detail or considers multiple items at once, which allows us to detect likenesses between them and integrate them. It is only because Amy knew that certain acrylic paints can be translucent, she had that detail, that she was able to have that activated by her general nerd concept of translucency. And analytic thought considers items in compact, or you could call it atomic form, And that allows us to facilitate very specific mental operations on them. How would I implement that? Which is the better one? What would I need to do as a next step? Think executive control network. So consequently, it is the movement between associative and analytical thinking, or which are other ways of saying different neural activation patterns, that is necessary for creativity. And I chose this picture here on the screen. I really liked it as a way of showing the broader activation of the nerds that are happening at different places in the brain, and that somehow comes together to give us the possibility of an idea. And we then go into analytical thinking and go, hey, it's a profile, before we then broaden our activation pattern again and then start following our next wave of associative thinking. So there's a quote here that I really like about creative geniuses. The creative genius may at once be naive and knowledgeable, being home equally to primitive symbolism and rigorous logic. He is both more primitive and more cultured, more destructive and more constructive, occasionally crazier, yet adamantly saner than the average person. And that was from Barron in 1963. And I like this particular chap here, who clearly looks like he can do an analytical piece of work, but also bursts forth with loosely associated creative ideas from inside himself. We're going to hear much more about creative personalities when we get into the theory of creativity a little bit later in the presentation, but here's a little pre-taste of that. And then one more thing, we're nearly at the end of this first part of the presentation now about the neurobiology. Some of you may be aware of something called Theory U. In fact, just looking at the attendees here this evening, I know that there are at least a couple of you that should be very aware of that. So Theory U was conceptualized by Otto Schémer, Peter Senge with some colleagues, and it's essentially a series of steps that allow for a creative process to take place, to presence what is not yet known, but what is emerging or wants to emerge. And it can be applied to businesses and much wider concepts than that as well. And what I've done here using my own associative thinking is applying what we've just learned about associative and analytical thought and nerds and all of this to Theory U. So you will not have seen this anywhere else unless somebody else out there did this, and I've certainly not seen it. This is just my interpretation. So it's a prototype that I've made, and we'll see whether it lands, whether it fits, but just something that I've put together to try and show you how creative process frameworks actually have a very strong biological basis in what is currently known about the creative process in the mind of generating insight. So let's begin. In Theory U, we begin with downloading past patterns. So that's a way of saying we are activating our abstract memories, what we currently know, the detail and the general aspects of a situation. And that is contained within nerds, of course. We're not focusing in on one thing, but we're downloading patterns. So we're beginning to bring in and activate information about what it is that we're trying to figure out. Then the next step down in the Theory U is about suspending and seeing things with fresh eyes. So suspending our previous ideas or our judgment. And what that then does is it begins to give us access to detail, to micro features, because we're now honing in on things that before we took for granted. Letting go of what we thought an item was, but actually breaking it down into constituent parts, seeing it afresh. Then we need to redirect our attention inside, also called sensing from the field. So at this point, we would be engaging broad, flat activation patterns with associative access to more distant neurons. So we're going into a broader field of awareness now where we're inviting in broader activation. And then letting go brings us down to this place of presencing, which can take some time. Once we've let go of all of those things and we've broadened our associative networks, flattened them out, we're now listening, sensing all of the information that might come in from the nerds. We begin to crystallize a vision and our intention. So we're now letting come from the networks. And as we begin to crystallize, that also means putting it into form, which means that we will begin to have spiked activation patterns for analytical thinking as we're trying things on for size, a little bit like Amy with her ideas about, would that kind of paint work? What do I specifically know about acrylic paint? Would it run on the window? Would it stay? Would it dry fast enough? Etc. Once we've crystallized, we can begin to enact our idea. And this is when we had Amy then beginning to mix paints, try different densities and colors, prototyping the new by linking head, heart, and hand. So at this point, we're moving backwards and forwards between the different activation patterns, as the heart is the associative aspect. Do we like something? Does something remind us of something that we're not so keen on? Our head, as we're analytically trying it on for size, and also our motor cortex, as we're carrying this out into reality, quite literally activating the neurons that make our hand move around. And then finally, the embodying, the performing of this, which is operating now from the wholeness. You could also say institutionalizing what we've done as we make it into a new tradition for ourselves. And at that point, it could be that curtain paint becomes a new thing, and Amy starts up a little business selling ideas for that, or writing a blog about it, or creates an exhibition of her curtain paint. So she will begin to lay down white matter between these newly connected neurons. Never again will curtain and paint be so separate in her brain that she has to really seek for that idea, but it will come immediately as new white matter connects those neurons firmly together. So that's just an application of what we've just learned to theory U. It just really lends itself to showing the associative analytical interplay that is necessary for creativity. And it is one way, one theory of creativity. And again, just a little taste of what we're going to be looking at as we go along. Okay, so we are now at the very end of the first part of this part of the presentation, which is about the more physical structures inside the brain, what is known about networks and nerds. So the key point to take away from this really is that the coupling between these apparently opposite default mode and executive control networks, or associative and analytical thought patterns, supports the production of creative ideas. And to make it even more simple, creativity is supported by connection. Okay. So somebody in the chat room is having a bit of an insight about how dream becomes reality, the movement between these different thought patterns and neural network activations. Yes, indeed. So a final quote to end this part of the presentation, Steve Jobs. He said, "Creativity is just connecting things. When you ask creative people how they did something, they feel a little guilty because they didn't really do it. They just saw something. It seemed obvious to them after a while." So that's another way of saying they used associative thought and the nerd became activated. Nerd is, of course, also an interesting word to use from the homonym nerd, as in a computer geek, with Steve Jobs. So nerds become activated and bring something. And then once you've realized that you can do curtain paint, it seems so obvious that it's almost a little bit embarrassing. How have other people not thought of that? Okay, so that's the first part that comes to a close. And we're now going to start looking at how brain damage teaches us about creativity. Of course, there are many different ways in which the brain can be damaged through acute trauma, injury, etc. I'm going to be specifically looking at neurodegenerative diseases because they allow us to look at the progression in the changes of creativity over time. We're going to start with Alzheimer's disease. So, in Alzheimer's disease, the picture that is here on the screen is showing you the specific areas that tend to be affected in Alzheimer's disease, and it affects both areas in the frontal cortex, the prefrontal cortex indeed, and the default mode network here in the parietal lobe. So you can see these are almost the exact places that we saw earlier in the default mode network. Let me just get that up on screen again to show you. Here we are, the default mode network. So can you see here on the right how much overlay there is between that and the areas of degeneration in Alzheimer's disease? So the way that Alzheimer's disease tends to present in patients is that they get problems with what's called episodic memory. Where am I? What was I doing? Who are you? And there can be problems with arithmetic, mental calculations, and also in some types of Alzheimer's, there can be spatial awareness problems. One patient that I read a case study about, for example, had a great deal of difficulty in putting on a waistcoat, because he couldn't really figure out how to get the arms in and how to move it around his body to get the other one in. And he tells a story of how he went to the church and he accidentally sat on top of the vicar instead of the empty chair next to the vicar, because he couldn't work out the spatial awareness around him. Now, Alzheimer's disease hasn't so far been shown to lead to what you might call objective increases in creativity. With the problems in the default mode network, that kind of makes sense. However, I wanted to mention Alzheimer's disease to you because creative therapy has shown to be really beneficial for people at the various stages of Alzheimer's. It can lead to more confidence, better communication, and a better sense of quality in life, which is essential. There's a wonderful documentary called I Remember Better When I Paint. So where you see different patients with Alzheimer's feeling more of themselves as they are painting, which is of course helping for there to be more associative connections in the brain, maybe bringing in more memories from the past, more of a sense of who they are beyond just what they've forgotten. So that's Alzheimer's disease. I've got a piece of artwork to show you from Charlie Harrison, who's in his mid-70s, and he paints. And here are some of his artworks, a little sequence of paintings here called Single Yellow Lines. So that is an example. Of course, not every person with Alzheimer's paints like this, but I just wanted to illustrate each of the different neurodegenerative conditions we're talking about today with a sample of the artwork that they might produce. So here, nothing that is too spatially complex, nothing that involves a deeper sense of symbology. You might say, of course, a line can symbolize many things. So we're going to move on now to other forms of dementia. So there's just a question about whether this is specifically for Alzheimer's. Different forms of dementia tend to target different kinds of the brain. That's actually part of the way that dementia is diagnosed, categorized by the part of the brain that is involved. So we're now going to move on to what's called frontotemporal dementia, which is a collection of different dementias that affect the frontal and temporal lobe. So the scan we see here on the screen is showing part of that, how the frontal lobe is affected, and a little bit here in towards the temporal lobe as well on the side of the head. There are different types of frontotemporal dementia, and they are diagnosed based on the sort of symptoms that a person experiences when they have this. So we're going to talk specifically about, two of them in detail, one of them a little bit more lightly. So the first one is behavioral variant frontotemporal dementia. When people start to have that, they develop what's called disinhibition. That's usually what the frontal lobe is doing for us, inhibiting us from doing things that we shouldn't be doing or we kind of think another person might not like. We make poor decisions and we become more emotionally blunt, and there might be a sense of apathy. We just can't be bothered. There isn't motivation. So that's more when it's the frontal lobe specifically that is targeted by this kind of dementia. There's another type called progressive non-fluent aphasia. So aphasia is a word that's generally used to describe problems with producing or understanding speech. And in progressive non-fluent aphasia, patients basically develop this kind of non-fluent agrammatic speech. So they know what they want to say, but the word just isn't coming. And they might also get a bit more hesitant, or there might be more errors in the way that they're producing the grammar. Then there's also semantic dementia. Now, this is where people lose what the word means. They might see an object and no longer understand what that object is used for. So there's now a problem about actually understanding objects, concepts, and words. So you can imagine that each of those three types of frontotemporal dementia have different effects on patients. So we're going to look a little bit more in detail about how they interact differently with the world around them. I'll start by explaining this picture that's on the screen here. This was a study done with eye tracking in the lab, where 9 patients from each of these 4 groups were recruited to come and look at this picture on the screen, and a little camera was looking at where they were looking. So what you're seeing on the screen, those colors that are floating around, are heat maps of where there's more focus on the screen. This top left picture is the control group, as you must have in any good study. So those are 9 neurologically healthy individuals of a similar age to the patients in the other groups. And you can see that their focus is really here on what's called the vanishing point in the picture, and even a little bit beyond that. So they're attracted by where the lines are leading them. Then here in the top right, we've got Alzheimer's disease patients. Now, you can barely see the heat map here. There's a very broad, loose focus, not really a specific point they're looking at. Remember, with Alzheimer's disease, there can be a lot of problems with the frontal lobe as well as the parietal lobe. So there isn't really anything, there's me speculating, but there might not be anything that they're relating this to. They might not be traveling into this picture to go anywhere specific with it. There might be a sense of disinterest generally in it. You can certainly say there is no specific point that Alzheimer's patients are focusing on. Then in the bottom left-hand corner, we have FTD. That's an abbreviation they're using for the behavioral variant version. So remember, the people who become disinhibited, they lose the kind of emotional focus. But interestingly, they look in a very similar way at this picture as those who have normal neurological presentation in this area. So there is something about when it's just the frontal lobe that's affected, it's not really changing their interaction with imagery. Now we get to the really interesting one, people with semantic dementia. So these are, remember, the people who are losing the concept, what concepts mean, what objects mean, the deeper conceptual knowledge. And where they're shown to be looking at the screen is actually in areas that have interesting texture. They're very interested here, for example, where the ground is. They're looking over here where there's some plants, where the line is, where the plants meet the edge of the gravel here around the tracks. They're interested in that over here as well, a little bit on the horizon, but much more about the detail of the picture. Certainly not as a priority here at the vanishing point where the controls were looking. So you could say that neurological change is effectively creating a shift in these people's attentional space from language, perhaps, to vision. We're going to see a lot more about why I'm making that statement here. Studies have shown that patients with semantic dementia are actually much better than healthy people in what's called a serial search task, and we'll do one together in just a moment. So if you show people 15 objects on a screen and ask them to identify one specific one, people with semantic dementia do that faster than healthy controls. People with semantic dementia will find an object out of 30 as fast as they find one out of 15, while eye tracking studies show that they are actually looking at a smaller area on the screen, which is fascinating. So it looks like when there are losses in certain parts of the brain, there is a more efficient visual search strategy that's emerging, and there is a way of ignoring distractors. So we're leading into this idea that people who might have had unrecognized artistic and musical creativity might suddenly have an emergence of those skills because of the neurodegenerative disease that's targeting the language function. So usually people, and we'll see this as we look at the artwork from different kinds of frontotemporal dementia, it's usually not about verbal or symbolic contents, and you'll remember why. The temporal lobe is being targeted. It might be about performing music, or most commonly about painting realistic landscape, animals, or geometric design. So we'll get more into that in just a moment, but I first want to give you the task. I just take this question here from the chat. So would these kinds of dementia be associated with brain injuries rather than something like vascular dementia, which would not be so specific? So if there were specific brain injuries to those areas, you would likely see similar presentations. I haven't got vascular dementia on here, as you're correctly saying in the chat. They're much less likely to be specific enough to give a specific presentation. These dementias that I'm talking about here are diagnosed based on their location in the brain. A vascular dementia often involves the frontal lobe, but they could also involve parts of the parietal lobe, parts of the motor cortex, even parts of the visual cortex. So you would get more of a functional deficit depending on where the vascularity is compromised. What kind of dementia is it when they forget how to use a fork? That can be a semantic dementia. It could also be a very progressed stage of Alzheimer's, where there isn't that kind of semantic awareness, conceptual knowledge. What is a fork? What do I use this for? The connection with the motor cortex isn't there anymore. Okay, so without further ado, I'm going to now give you a word for an object that is on this screen. It is your job to find it as quickly as you can. So the object I would like you to find is a hot air balloon. So as soon as you find the hot air balloon, I'd just like you to type yes in the chat box. A hot air balloon. Well done. Somebody has got the hot air balloon. Let's see if anybody else manages to find it. And I would love to hear from you how you did that, okay? If you could just type a few words about your strategy. Did you just look randomly around the screen hoping it would pop out at you? Did you start in the top left corner, working your way systematically around? Did you go color by color, focusing on one of these 4 colors at a time on the screen? What did you do? So somebody here was using random search, hoping it would just pop out. Yes. We've got somebody else who was systematically scanning top, left, down, and then across. Yes. And then another systematic search as well. So, of course, there are different ways of doing it. You could say that hoping it will pop out is quite hopeful. That can be a matter of luck. It could take a long time, or you might be the first one that gets it. The systematic one is also a matter of luck in a way, because what if it is in the bottom right-hand corner and you've systematically looked at everything, but you're more likely to find it that way. Whereas if you are just hoping it pops out, then you could be looking at it for quite a long time and give up in exasperation because it keeps eluding you. So I'm going to give you one more, and this time what I would like you to do is focus on one color at a time, okay? So we've got red things, blue things, yellow things, and green things on the screen. Do it color by color, just searching within those, maybe systematically or maybe randomly, but do it color by color. This time the object I would like you to find is a rabbit. So that was somebody who found that very quickly. Yeah, so several of you have already spotted the rabbit. Here we are, more people arriving. Excellent. So I asked you to do it color by color because that is a way where you are effectively focusing your attention on only a quarter of the stimuli on the screen, which gives your brain the ability to scan that much more quickly. You could even do it randomly within that color with less risk of missing it because you're hoping that it will pop out. And of course, it depends on what color you start with, but you will get there eventually. So those of you who started with blue probably got that very quickly. So if you like that kind of thing, it is a way that you can train your brain to very quickly do serial searches. There's a brain training app called Peak that I recommend. You can get it for free, and you can also get a professional subscription that costs some money. But it is fun, if nothing else, to sit and train yourself in getting very good at scanning things. So we're going to learn a little bit more now about semantic dementia. And essentially what it appears is that there is an enhancement of visual search function in people with semantic dementia, which is because they are having more functional connectivity in the dorsal parietal network. Brain scans show that there isn't a specific new density that's arising, but there is more functional connectivity. So you could say in a way there's more white matter being laid down and faster connections in their strategizing and ability to scan a wide area very quickly. So someone in the chat is now saying, like doing word games and discovering that they're much more quickly, it can do them much more quickly by relaxing and letting them come. Yes. So going into a less of spiked activation, which means you're looking at one thing at a time, And you might, in fact, never find the word that you're looking for if you don't allow those nerds to become activated that would give you the word that you're looking for. So what's really interesting about semantic dementia patients is that even as their condition is deteriorating and they're finding less pleasure in things and life is, of course, very hard, they still seem to be able to find joy in doing jigsaw puzzles. People describe seeing a lot of pleasure in them in completing a jigsaw puzzle, almost obsessively having to finish that jigsaw puzzle before allowing it to just rest till the next day. They also enjoy playing solitaire, patterns on the cards, finding coins, and gardening, which of course is also about a kind of pattern recognition, finding weeds, seeing how things are flowering. So things that are to do with visual search and a result that comes out of that. And what I'm showing you here on this screen is an artwork from an anonymous artist that was included in a study on patients with semantic dementia. And it was the last artwork that this artist painted before their death. And I found it quite poignant to see this expression of what's obviously going on for them, perhaps in their inner universe, or how they're experiencing the world around them. I find it particularly fascinating to see this almost obsessive repetition of dots and patterns within the painting, the lines on the faces, the lines around the eyes, down here on this clothing, all the little dots, the little circles that are here. So this is something that is quite typical for people with semantic dementia. And there was a transcranial magnetic stimulation study done. Those of you who were here for the Neuroscience and Spirituality seminar will remember that that's a way that you can either inhibit or overactivate a part of the brain. So a number of neurologically healthy people were chosen, and they did TMS on the left frontotemporal lobe to inhibit it. So this is the same presentation as you see in people with semantic dementia because it's degenerated, but TMS allows you to temporarily inhibit it for about half an hour. And they found that the people that they did that on, not everybody, but quite a number of them had enhanced creative components of certain skills. Not that their drawing ability per se was better, but certain abilities, for example, capturing perspective. So remember how these patients looked at those railway lines, very obsessed with the texture and the movement between things. They're very good at representing the kinetics when you do TMS to that part of the brain, the movement of things, and highlighted details. So they are capturing those in a way that is improved in comparison to when they haven't had those parts of the brain repressed. Interesting, they also get better at detecting commonly overlooked duplicate words when they're proofreading. And perhaps that's not a surprise given how well they do at serial search tasks. So that's semantic dementia in a nutshell in relation to creativity. And we're going to move on now to the next frontotemporal dementia, which is progressive non-fluent aphasia. And there's a very famous case study, an artist called Anne Adams, whose artwork I'm going to be talking about in this section. So just to begin with, what's generally seen in patients with progressive non-fluent aphasia, remember they are slowly forgetting words, can't find the right word, their grammar deteriorates, although they still know what things mean. What you tend to see in their artwork is an unorthodox use of vivid, unconventional colors. You get intricate, repetitive, what's also called perseverative, geometrical designs. And there is something quite unique about their perception. So we're going to talk later in creativity theory about the act of the creation. And they also have an obsessive nature, which is to do with motivation, a bit like the semantic dementia patients who are very motivated to finish the jigsaw puzzle. It's a very strong motivation to complete something. And the painting that I'm showing you here is called Pi by Anne Adams, and we're now going to look at a few more of her artworks as it progressed over time. So she had a doctorate in biology and developed progressive non-fluent aphasia in the latter part of her life. The first picture up here in the left-hand corner is a landscape drawing that she did 12 years before her diagnosis. She really enjoyed painting landscapes, and this is a representative sample. So, colors that are suitable, muted for a landscape, a house, without any kind of excessive detail, and, a setting of the scene, quite pleasant. 6 years before her diagnosis, here is a representative sample. Now look at the repetitive patterns and the much more striking use of color that appears in her artwork. And then, after diagnosis, a painting that she did of a house, and notice the level of detail now, the repetitive nature of all of this tiling detail, the brickwork, you can't really see it here on the screen, but the intricate brickwork, the way that she's shown the difference in color, how the light lands, how she's chosen that particular house because it is a repetition of a theme as it goes higher and higher up, almost musical in nature, a sort of movement that is progressing as the house goes up. The level of detail here in the foliage of the trees, very different to 12 years before, where there's just a kind of impression of trees, a few brush strokes. So you can see here, I find it fascinating how her type of neurodegenerative disease, the progressive non-fluent aphasia, was affecting her artistic expression and what she was obsessed with and how she was expressing it. And perhaps even more interestingly, this artwork, also by Anne Adams, which is called Unraveling Bolero. So she got obsessed at a certain point in her life with listening to this piece of music called Bolero by Ravel. And what she didn't know at the time was that when Ravel composed Bolero, he was also affected by progressive non-fluent aphasia. And in fact, as he was composing Bolero, he was reiterating the same piece of music over and over again with different variations. In fact, he said he wanted it to be something that was free of meaning in a way, but that incorporated more and more aspects of the orchestra. And what Anne Adams did was she transcribed her experience of Bolero into this piece of art here. So a very beautiful story within a story without her awareness that the composer of this piece of music also had progressive non-fluent aphasia. And as she explained, what this artwork represents is the size of these squares is the volume of the music. So it starts out very subtly and builds in intensity until the very end. There's a total unraveling within the orchestra. So I'm going to play that piece of music for you when we have a break in just a moment so that you can perhaps get a sense of this piece of artwork here in relation to Anne Adams' perception of the music and her translation of it. So we're nearly at the end of this part of the presentation now on neurodegenerative disease. Just to sum up a little bit, is it really that language is something that hinders our spontaneous creativity? So if we focus on language, if we deliberately focus on language, the hypothesis in neuroscience now is that that might be inhibiting spontaneous creative thinking. And if you remove those constraints, for example, in these people who are experiencing different problems with aphasia, maybe that is enabling dynamic processes that is leading to the novel recombination of ideas. So is it that when we are putting things into words a little bit too quickly, or we get too focused on a concept? Think now, for example, about feline and just being with that one concept and that word. You need to broaden and let go of it in a way in order for the nerds around to be activated to bring in more free association, leading perhaps to the novel recombination of ideas. If Amy, our artist that we heard about earlier, had only stayed with curtain, she would never have arrived at paint. So a final slide now, just to sum up, different brains make different kinds of art. And where we are in our lifetime, where we are in our neurodegenerative process, creates something very unique in us that we can also express in a unique way. That is really a way in which we are capturing our unique biology through our artistic creation. So creativity is unique to the individual and their journey through life. And a quote here from Picasso: "Every child is an artist. The problem is staying an artist when you grow up." And I would add as a little side note to that, staying an artist as your frontal lobe and your analytical thinking develop and make you become much more point focused on things, and perhaps losing a little bit of this more associative free thinking daring nature to put things together in a way where we just don't care if people like it or not. So we're going to have a little break now. I am going to put on Ravel's Bolero for you, and we will be back here at 10 past the hour for the last 50 minutes of the presentation. So I almost hate to interrupt the Bolero there, but we will have to slowly turn that off so we can get on with the presentation. So we've got 50 minutes now to cover creativity theory, idea creativity, and a little surprise at the end. So let's see how we get on. Now, I already mentioned to you Theory U in the first part, one framework for encouraging creativity. There are researchers, psychologists, who've looked at specifically what kind of qualities are necessary for creativity to arise and what actually are the components of what we call creativity. So we're going to look at it from different perspectives, starting out with the neuropsychology point of view. So this is what I'm doing my PhD in, and what my colleagues have found is that there are three major components of creativity. The first one is ability. Now, for an artist, that could mean the ability to actually use a paintbrush or play an instrument, but it could also mean that you have to have a certain expertise in your domain. In essence, you have to know something about something in order to do creativity. Otherwise, there would be nothing for you to associate or create or to even have a creative response to. The second thing is creative thinking skills. Now, that's only 10% really of what it's about. We'll see the third part, motivation, is the 90%. But creative thinking skills involve working memory. So that means you have to be able to maintain and manipulate information. You need to be able to combine known things in a new way. So we know a little bit about how that happens in the brain now. And you also need fluid intelligence, which is about adapting to new situations and reaching higher levels of abstraction and complexity in your thinking. So fluid intelligence is a different kind of intelligence than crystallized intelligence, which is what tends to be taught in schools. Crystallized intelligence is this vast storehouse of data and skills that we learn through experience. We practice them and then we gain them. That kind of crystallized intelligence isn't what creativity is about. It's about putting things together in a new way, even zooming out, seeing things from a different perspective and coming back in. If you only know stuff a bit like a robot, then you wouldn't necessarily know how to do that unless you have some very good neural network programming. So those are the creative thinking skills from a neuropsychology point of view that are necessary for creativity. And then the vast majority of it is motivation. And if you just think about that, are you committed to doing the task? Or are you doing art because your art teacher in school is telling you to do it and you're really not interested? So motivation is best when it arises from the inside. You do it because you want to. And the other thing is, of course, focus, drive, perspiration. If you begin something but you don't end it, you don't necessarily have the work of art that you want to have. So remember the people with semantic dementia and that obsessive quality about doing the jigsaws, or even Anne Adams in her intricate drawing of patterns. To begin something, to persevere and to finish it is required for art from a neuropsychology point of view. So that's one view of it, and we'll just quickly take a little detour via fluid intelligence and the neuroanatomy of that in the brain. So fluid intelligence just so happens to be located primarily in the lateral prefrontal cortex. You might remember that that's also part of the executive control network. It is a major hub of fluid intelligence that allows us to control what we're paying selective attention to and inhibiting stuff that isn't useful. So in fluid intelligence, we both need to be able to move between ideas and up and down concepts, but it's not the same as being distracted or just following one train of thought that gets us to a completely different place than where we began. It's about the recombination of concepts that requires us holding them both at the same time and seeing how they're connected, or feeling that there is a connection and then feeling where that specifically leads to. So those of you who were with me for the neuroscience and body-mind presentation will remember about set shifting as well. It's part of the executive functions of the brain. And then we have this idea of solution generation in divergent thinking. That is what we use fluid intelligence for. So without further ado, we're going to start getting into the much more interactive part of this now. And we're going to do some exercises in divergent thinking. So here we go. What you're seeing on the screen right now is not divergent thinking. This is a typical IQ test called Raven's Progressive Matrices test. That is convergent thinking. That means that this puzzle here has one answer. So it's either right or wrong. Everything converges onto one single solution. So if you are somebody who likes to work that out, you can see here in the bottom right-hand corner, there needs to be some kind of shape, which will probably be a diamond one like those there. And one part of it needs to be colored black. So each line has a different segment that's colored black. So we could imagine that probably be a diamond that looks like that one, colored black in that area there. That's one correct solution. How very boring. Instead, divergent thinking is when there are many answers to something. So you diverge, traveling along the flat activations across many nerves in your system. So we're a little bit short on time, so I'm not going to give you 2 minutes for each round. You're going to have 1 minute for each round of this. In the first round, get your pen and paper ready now. You're going to be writing some things down. I'm going to show you an object on the screen, and your job is to think of as many uses as you can for a barrel. Go. As many uses as you can think of. Last 8 seconds. 3, 2, 1. Okay, pencils down. Now, count how many uses you thought of and just type that into the chat box so we can get an idea of how wide you went with this. 8, that's fantastic for 1 minute. 8 as well, my gosh. 15, we have some very divergent thinkers here this evening. Another 15, 12. Gosh, I mean, normally when you apply this test to people in a clinical setting, 10 is a good average for 2 minutes. So I guess we have a very self-selected audience who's turned up here tonight who've got such high averages for half of that time. Very good. I'm very, very impressed with you. Let's go straight into the second round after we talk about how you did it. So those of you who scored 15 and those who scored 12, could you write a line about how you did that? What was your strategy? Was it just waiting for the next thing to come, or how were you searching through your mind for those uses? And those of you who scored 8, of course, I'm also interested in hearing from you. It's just the incredible high scorers that I'm finding a bit of an anomaly here. So somebody did it through free association and pleasure. That sounds like an excellent way to engage creative thinking, flat activations of nerves. And then somebody else who looked at the barrel, thought of the unusual first, interesting, so that she could add the more boring quickly at the end. So that's an interesting strategy. The weird things first and then the obvious things towards the end. Okay, so that's 2 possible strategies, and it may be there's even more ways. So we're going to test you now by doing it a second time. So here comes round 2. I'm going to give you a new object, and this time the object is a paperclip. So write down as many uses as you can think of for a paperclip. Okay, last 3 seconds. 2, 1, and pencils down. Okay, tally up your score this time. Let me know how you did. 10. So that's an improvement and the same as before. This time somebody a little bit less than before. Okay, so sometimes when we do it for the second time, we get into a little bit more of a squeezed state because there's a performance that's kind of being required. And sometimes it becomes easier the second time because we have a new strategy, if you like. The point of this really is that if we allow ourselves to be inspired, exposed to others' ideas, that can support our creativity. Sometimes hearing how somebody else did it makes it easier. And we can also go into competition with ourselves and feel the pressure to score more than we did before. And perhaps a paperclip is less inspiring than a barrel, I don't know. Or perhaps, as one person is saying here, there was a delay because of trying to spell things correctly, also very valid. In any case, all of that are examples of divergent thinking. One thing leads to many. So this leads us to the idea of what are the attributes of a creative person. And what you just used, some of you, to do that exercise, you might find that repeated here. So various researchers, I'm not quoting all of them by names, there are many, but this is a collation, showed that defocused attention, I think somebody said before, free association and pleasure, a tendency to not focus exclusively on relevant aspects of the situation, but also notice seemingly irrelevant aspects. So you could also relate that to the person who said, focus on strange uses of the object first, right? So that's a way of using associative flat activation in our thinking. Another attribute of creative people is they tend to broaden the focus of attention, which is different to just defocused. Because when we broaden the focus of attention, we're overcoming fixation. So it's a mental state of individuals who are unable to move beyond a known problem-solving approach to generate a new one. So that's when they can get stuck in an analytical spike activation pattern. Okay, so getting stuck there is different to on purpose defocusing the attention. So if you're somebody who tends to get stuck in it, you would need to coax yourself into switching out of that mode. That's something that you can do. You can be creative and analytical, but you would need to on purpose switch your mind. And you might be somebody who already has a defocused attention that likes to notice irrelevant things around what's going on. So that's the difference between these first two. Then another trait is high sensitivity, including sensitivity to subliminal impressions, stimuli that are perceived, but which one is not conscious of having perceived. So remember about the nerds, level of memory detail available in nerds depends on how much we noticed, being sensitive to our environment and encoding that. It gives us more ways of moving through the creative connections in the brain. More characteristics, risk-taking, like children, caution to the wind and do it anyway. Tolerance of ambiguity, not settling too quickly on something, and delayed gratification. So that's also about motivation. Can you continue going, even if you want it to be done now, but it needs more time, more space? Can you wait for that feeling of satisfaction? And also, it's shown that creative people often have strong leanings towards non-conformity and unconventionality, which I think is rather fabulous. So it tends to be more unconventional thinkers that have the thought patterns that would allow creativity to arise. I quite like this little cartoon here. This is Wonk. He's my designated hitter. So the smaller caveman has obviously identified some sort of deficiency in himself and thought creatively, should I go to the caveman gym? Should I learn martial arts? Should I get a big Tyrannosaurus Rex pet? You know, and he has decided to recruit somebody to be the designated hitter for him. So we're now going to look at specifically one researcher called Csikszentmihalyi from Hungary, who is most known for having identified the state of flow. So he coined that word after lots of research widely across people who are able to enter that kind of state. And his follow-up work to that book called Flow is about creativity. So according to Csikszentmihalyi, creative people are necessary for humanity's survival and thriving. If we only had in our tribes people who stayed with the same stuff all the time, we would probably die out if we couldn't adapt to changes in the climate, very relevant at this time in history. Opportunities that arise, the possibility of thinking, if I combine a little bit of soot with my finger and a cave wall, I could actually make a lasting impression. So if we don't have people in our groups who are able to think differently and combine new ideas, we would probably exhaust the resources that we have in the area that we're in until there's nothing left. And then what? And he then analyzed interviews from almost 100 exceptional people, poets, artists, biologists, physicists, business people, politicians. And he found the following traits: that it wasn't determined by genes or early life, their level of creativity. Their childhood could have been supportive or difficult. Now, this is something that's a little bit disputed, particularly for music talent. Musical ability does have a genetic component to it. For example, perfect pitch, that runs in families. But anyway, he found that the kind of creativity he was looking at wasn't solely determined by that. You don't have to have creative parents in order to be creative. And it's not about what trauma you experienced in early life. There's some extraordinary artwork coming out of Syria at the moment. Literally people making statues out of bombed buildings, very traumatic experiences, who are using that in a creative way. He also says encounters with external events teach these people to adapt. So they're using fluid intelligence. They're not allowing the external events to dictate who they are, but they're using them to create something new with this sort of fluidity. And they also don't consider themselves as a victim, an interesting personality trait. Instead of being shaped by what has happened to them, they shape the events around them to suit their purpose. Again, these sculptures arising out of the ashes of the buildings in Syria that have been bombed. Very poignant. So the lesson from Csikszentmihalyi about becoming a creative person is to be a creator of your own life and not to think you're a victim of circumstance. A popular saying around that is, if life gives you lemons, make lemonade. Csikszentmihalyi had a few other thoughts about the components of creativity. So remember we saw the neuropsychology components. According to Csikszentmihalyi, creativity can never be solely about the creative individual. So this wasn't part of the neuropsychological perspective, but he says, according to him, 3 components are needed. There needs to be an existing domain, an area of knowledge that the creative person is familiar with. So this is the same as the neuropsychological aspect. You need an ability, you need to know something about something. So we can relate that to automaticity. There has to be something that you are sort of versed in order for that to become a manner or a subject for creative expression. He then says the act is also required for creativity, the act by the creative person, which could involve approaching an aspect of that domain in a new way, which is to do with fluid intelligence, finding a new way of combining or expressing something that is known, but in this way that hasn't been experienced before. So this is where I put this illustration over here of this pink flamingo who has decided that pink is good and all the other birds are white. Of course, it may be also due to the fact that it's eating small red things in the water, but there we are. I like how that it was standing out. It's a bird, but it's not the color of everybody else. So within its domain, you can consider it quite creative. And then the field itself, the creative person's peers. So this is where Csikszentmihalyi is a little bit more controversial. He essentially says that if we do not have the recognition of the field around us, our peers, then the creativity can't be considered real. He gives the example of Johann Sebastian Bach's work that only became considered creative, recognized after centuries of being dismissed. So interesting. We're going to do a little exercise on that in just a moment. I'm going to show you some stuff and you'll tell me how creative you think it is. Just pointing out here that for Csikszentmihalyi, he doesn't mention motivation in his theory, and I think that is a very important part of creativity. You do have to begin it to do it, and then you have to finish it before you can sort of present it and show it, if that's part of your creative process. So on the screen now is an artwork, and I'm going to gradually add more and more to this, and I would like you just to type yes when you consider that this is a work of art, okay? So is there anybody who just seeing this here feels that this is recognizable as a work of art? Okay, we have a taker here who likes this as a work of art, would hang that on their wall quite happily. Okay, I'm going to add another one. So it's a collection of pieces that we're seeing here that's growing. Is there anyone now who would like to have this collection of art on their wall? Okay, we have another taker. So I'm going to add more now. Here's a third piece. The collection is growing. It is quite conceptual. Okay, I'm going to add another one. We don't have any more takers right now. And another one. Yes, okay. We have a few here who like this collection. Okay, now we have people who are taking it. And that's the complete collection of these 6. So 6 pieces of art. Yes, so we're now almost all in agreement. I think we're just missing 1 or 2 to agree that this is indeed artwork. Now I'm going to tell you what domain this is to see if you will then consider it artwork. The domain is that these are minimalist film posters of Disney classics. So does that make it a little bit more easy for anyone who wasn't on board to begin with to consider that this is actually very creative? We have, starting in the top left, can anyone guess what that Disney classic is here? Perhaps not the easiest one. It's Pinocchio. Well done. Yes, indeed. That's Pinocchio's nose growing there. And this one here, we have Aladdin. Here we have Cinderella's shoe. Down here, that's obviously a hook, so something to do with Captain Hook. Can anyone tell me what this one here is? This one in the middle, in the bottom? Lady and the Tramp, very good. Excellent. Someone said Dalmatians. No, different kind of dog, but you are in the right nerd kind of area. That's a very funny example of activating Disney classics and then getting something to do with the dog, but it's the other dog one. And then bottom right is Alice in Wonderland. This is the smile of the Cheshire Cat that's here, okay? So because that was a lot of fun for me, at least, I'm going to do another one with you, but I'm telling you the domain up front here. So these are minimalist film posters that are classics, classic films. Is there anyone who knows what any of these minimalist film posters are representing? Any one of these three? Any takers? Psycho, absolutely. That is indeed Psycho over there. Man with knife, lady under shower. Any other takers for these two? Grease, fantastic. Yes, that's Grease. Here we have cigarette being stomped out in a most alluring manner, waiting for someone with a comb to come and approach her to dance. And Clockwork Orange, you guys are great. Well done. So, excellent. Let's bring on another set of three just because it's fun, and then we'll move on. So these are more difficult. These are more modern minimalist film posters. They are all from slightly sci-fi type films. Sci-fi, slightly surreal fantasy type things. Any takers for these? Inception is indeed the middle one. Well done. What about the one on the left or the right? Much harder, perhaps. Any ideas? This one here, a little person inside a larger blue person. Or this one over here, steps leading up inside this blue thing to some kind of white opening there. Any ideas? The right one is about the guy who was trapped in an unreal world. Yes, indeed. Does anybody know what that was called? He was being filmed without knowing. His whole film was in fact a reality show and he didn't realize. That's it, it's the Truman Show, well done. And somebody has said the Blue Aliens. What is the film called that's got blue aliens in it? We're on a planet that's all this extraordinary flora where they have a home tree and there's humans that come. Avatar. Excellent. Well done. So we have all three. So notice what you're doing here to get this. You're getting very minimal conceptual information and then relating that to the domain, which then allows for the creativity to be appreciated in a different way. As you're having to use this very abstract knowledge, a lot of nerds being activated there in your brain as you were doing that. So well done. So now we come to this important point about how can we access creativity. And de Bono was a huge name in the field of creativity. Edward de Bono, in fact, came up with the concept of lateral thinking and many other types of thinking. He trained as a doctor and gave up his medical career to investigate creativity and teach it. And he said that some people think that in order to be creative, you just have to remove anything that stops you from being creative. Perhaps removing inhibition is useful for accessing creativity. You sometimes see that in people with brain damage from neurodegenerative disease. We saw that. If you're not inhibited by the specific meaning of a word or thinking you can't express yourself, you might be able to let something come out. But what about if you have a man who's tied up with rope? He's not going to be very creative while he's tied up. That would be very hard. But if you remove the ropes, does that necessarily make him into a producer of quality artwork? We don't know. Maybe, maybe not. And this is the same for other approaches that are disinhibiting. For example, alcohol or drugs that are also sometimes used in an attempt to facilitate creativity. Removing inhibition only exposes what is below. And I just put on here a little note, this is more from psychology now, but the lower self can also be a very powerful and potentially creative disinhibitor. I had a client once who told me that they were so annoyed with their ex that when the ex went on holiday, they went round to the ex's house, opened the door with the key that they had kept, and sewed prawns into the lining of all the curtains so that when the ex came back from holiday 2 weeks later, the house was uninhabitable through the stench of the rotten seafood. So that is very creative in terms of revenge or punishment, but it's not an integrity and it is destructive. So sometimes strong emotion can also be a disinhibiting force and show all sorts of creativity that lies under the surface, but not really an integrity with other people. So how can we access creativity? How can we learn idea creativity? This is different to artistic creativity, which is more about an aesthetic judgment. What color should I use? What note would go well with this? What instrument should be playing that? What lens should I use on my camera? This is about judging what is aesthetically right. That's different to producing new ideas. So I like this little graphic of all these little ideas that are always waiting to come and find you. So we're going to move on to that in just a moment. We'll round up this part of the presentation with this key point. Creativity theory has different components depending on who you ask. Apparently, it can take some knowledge, it can take a fresh approach, recognition by others, lots of motivation, I really believe in that, willingness to practice, and also perhaps lowering one's inhibitions, if indeed inhibition is in the way. So what you need to take away from that is creativity can be developed. A quote from Salvador Dali, "Have no fear of perfection. You'll never reach it." So we're almost at the end of our presentation now, but this is really the interactive creative part we've landed in. How to develop creative thought habits so that creative ideas can come more easily to you. There is a neuroscientific basis for the techniques I'm about to share with you from the first part of the presentation. They evoke the use of working memory and fluid intelligence, which we saw as the neuropsychology approach to creative components. These techniques encourage interplay between executive control and default mode networks. They encourage a switching between analytical and associative thinking, spiky and flat activation patterns. And they also increase neural efficiency. You will make better use of glucose resources in the brain during cortical task performance if you practice these ideas. You will be able to use them more efficiently because you become used to thinking in these kinds of ways, and then you're able to achieve more with fewer glucose resources. To begin with, it can feel really hard, and then when you get into the swing of it and you become practiced, it seems much more effortless. So we're going to start with a technique from Edward de Bono. As I said, he invented lateral thinking, this term. I mean, the idea may have existed before, but he coined that description. So lateral thinking, how do you do it? He says, number one, you have to define the problem. So that's a form of analytical thinking, right? You are focusing in, narrowing in, perhaps verbalizing the problem you want to work on. Then he says, you obtain a single random word, and I'm going to give us one of those as we do an example of this together. And then you see how that random word can trigger ideas that might help to solve the problem. So let's do this in practice now. This is a pre-worked example. It might be that the specific problem is a seaside town wants to attract more tourists. You then look up a random word. You might get out your dictionary and look up a word, and your finger lands on joy. Okay. And then you think, well, how could joy help me solve this problem? And you might think of, well, as you're following the more flat activation, the nerds in your brain around what is joy, how could it be used, you might organize a happiness festival once a year in that town. You might give awards to people who are happy. You might set up a school for training clowns and employ those clowns in restaurants and hotels. You might have an annual clown conference. So all of that just inspired through the word joy and the connections you can make to improve the town's tourist situation. Okay, so I hope you get a sense of how that works. We're going to do an example together now. So I've defined the problem. I procrastinate instead of filing my taxes. This happens every year. So the random word, I'm just going to ask everybody who's present to choose a number between 1 and 6. So please, everybody, write a number between 1 and 6, and I'm going to choose a table and a column and a row and a word based on what you write. So we've got 3, so I'm going to choose table number 3. And then we've got 5, so that would be column number 5. And then we've got 6, row number 6. And I need one person to write one more word, one more number, please, between 1 and 6. And number 1. Okay, the word we've got is padlock, a padlock. Okay, how could we use padlock to solve this problem about procrastinating instead of filing one's taxes? A padlock is a kind of lock that you put onto something, and there's a little key you turn and the lock springs open. So it's often used to, for example, hold a gate closed, or, you know, in cartoons, it's often something that somebody would be trying to pick to open and the little thing springs open. So someone says, that's really not helping. Come on, people, a padlock. I procrastinate instead of filing my taxes. How might a padlock help me with that? The concept of padlock, what a padlock brings you to associatively in your mind, or quite literally padlocking something. As I was writing, you feel locked in life, so you have to go outside to fill them in. Excellent. So I have to pop open the padlock that's keeping me in this trapped situation, and I have to literally go outside. Somebody else is saying, lock myself up until it's done. Yes, it's a very good use of a padlock. You can't leave the room until the taxes are filed. Somebody's written a safe. Okay. Do I feel safe enough to do my taxes, or do I put myself in a safe? Keep all the receipts in a safe place. Excellent. So it's very easy to file my taxes. I can't procrastinate if it's so easy that it's just color by numbers. Very good. So I'm just waiting to see if there's another idea that comes. But I think you begin to get the idea that what you're doing essentially in your neural networks is you're analyzing a problem, analytic thought, and we're bringing in a word, and then you begin to, initially there was this isn't helping, but then as you begin to broaden out conceptually around that word, what does it bring in for you? And so we've got these different associations that we have. Somebody else here wrote, my first association was to go and rob the treasure box of the tax people. So this is also part of the creative process. Don't write off any ideas. So perhaps steal the money from the tax people instead of giving your returns to them, right? Or get a responsible accountant to do it for you, someone who's safe as houses. Excellent. You guys are doing really, really well. So as you can see, we travel further and further in our associative networks. All we needed was a trigger. That's what we need in order to broaden the focus, to get away from, I can't do my taxes because I procrastinate. Okay. We'll go to the next example. So that was lateral thinking. Now, parallel thinking. So De Bono has a particular technique that he calls the 6 thinking hats. It arises from this principle. When we think, we receive and process a lot of ideas. That's because of the automaticity and salience that's happening in the brain. Remember, right at the beginning, we spoke about that. And that's confusing. We're getting emotions, we're getting facts, enthusiasm, logical, critical, creative thoughts all at once. What do we choose? How do we progress with that? So according to De Bono, the goal is to do one thing at a time. So he's talking about narrowing in an analytical way, the focus after we've gone very broad. So we can better reflect, deal with the problem, take decisions, and avoid the confusion of ideas. So that's also about coming out of the default mode network of just randomly associating and coming into a more problem-solving mode with that information. And we also need to avoid censorship of new and unusual ideas, such as just robbing the taxman instead of filing the returns. So if you do that as a group, this is often used in businesses. In fact, De Bono and his representatives and trainees make a fortune going into businesses teaching these techniques. So if anyone is looking for an alternative career, being creative and teaching that, there's one way to do that. If as a group you do this, it allows everybody to look in the same direction while appreciating that people have different approaches. So I'll go straight into it now to show you. He identified these 6 thinking hats, 6 phases with hats of different colors that represent different ways of thinking. And this is parallel thinking because you selectively engage one at a time with these different thought processes. He says it's easier to juggle 6 times with one ball. I might be able to manage that, rather than once and keep 6 balls in the air. So here are the hats that he identified. The first one is the neutral hat. So this is about facts and just the facts, the information that is known or that is needed. For example, I've put a problem down here that we might try and solve. I would like to have more friends. So from a neutral hat perspective, the white hat, we might say, well, I need a list of your current friends and family to understand how broad of a problem is this? You know, do you have 300 friends on social media, but you only ever see one friend in person? That's facts. So identifying both what we already know, but also what we need to know to bring us forward. The next hat, these are not in any particular order, by the way, they're just how they're presented here, is the blue hat, the managerial hat. So this is a bit of a metacognitive thing where we're thinking about the process, the abstract global vision and conclusion. So this is an executive kind of network that is choosing to think about the process of solving the problem. So we're not getting into the contents of the problem, but how we might do it. And that one might, for example, ask of the other hats, what is the summary of your thoughts? What is the vision that we're working towards globally? Let's keep on track. What are the conclusions that we're making each time something new is being added? And the process itself of doing this, are we going to think one hat at a time only once, or will we be going round in circles? Will we be hearing the hat first that speaks first, or do we have an order, etc., etc.? That's the managerial thinking process function. The green hat, creative possibilities. What might be the possibilities here if we let go of all caution? What might be the alternatives and the new ideas? Let's rob the tax people instead of filing returns ourselves. That's where you use lateral thinking. So the lateral thinking fits within the parallel thinking process. So something the green hat might say is, let's think about this differently. Then the yellow hat. This is the unconditionally positive hat that only explores advantages, figures out where there might be value, benefits, and opportunities. This is the incurable optimist. So this one might say, well, people will of course help with this because everybody understands that I want friends. Everybody can understand such a basic human need. And if I put it out on social media, it's going to get loads of likes and it will go viral and I'll suddenly have lots more friends. And of course, they're going to want to meet in person because I've said that's what the problem is, etc., etc. So this incurable optimist, positive thinking hat. Then the red hat, which is the intuitive hat. This one here goes only on emotions, hunches, and forebodings. So there is no explanation needed from the red hat. It will say things like, something feels painful to me. Or I get a hunch that there is an imminent change coming. Or I have a foreboding, which is a sense that something negative might be coming. And we need to be very careful as we go forward. And it doesn't need to give any explanation, any information. It's just, this is how I feel. And then finally, the black hat, deploy with caution, but do use it. The hazardous hat, critical thinking. What are the omissions we may have made? Why might this not work? So this is a little bit the opposite of the positive hat. It might say something like, we just don't have the skills for this. If we already knew how to have more friends, we would already have more friends. We're never going to solve this, etc. So critical thinking is also about noticing what might be the flaws in the requirement or the problem that's being put forward. Is the problem really the problem, or is there another problem that needs solving for it? That's the hazardous hat. It sees where the issues might be that need solving. So I'm just going to ask you to choose whatever hat that you want out of these. And somebody's saying, yes, it's allowing all the different voices to have their say and being really democratic in listening to them one at a time. So I'm just going to invite you to choose whatever hat you want, and I'm going to trust that you somehow choose different ones. And we're going to work with this problem. I would like to have more friends that I see in person in my life. Okay? And so just try on a hat for size. I'll give you a minute or so just to feel, sense, think, analyze, whatever the hat requires of you. Look at what it says on the screen and just then write in the chat box the color of your hat. So it might be white, and then what comes to you from that hat's perspective. And let's see what we harvest together. So I'll just disappear myself for a moment so you can see all the hats clearly. Okay, so we've got somebody who's chosen the green hat. Wonderful. So somebody's going to be doing some creative thinking about wanting to have more friends that one sees in person. And from that perspective, the creative idea is to join groups with similar interests. Absolutely. So follow your interest, follow your passion to find people who might be like you. And then, of course, you would see them in person because you would turn up for the group. Like a walking club. Fantastic. Yes. Excellent. Very good idea from the creative aspect. Somebody's chosen orange, the positive approach. Somebody else has said green here. Create a lonely club that has crazy ideas for trips, that makes people curious to join and see what it's about. Wonderful. So entice people through curiosity. Very creative. And call it the lonely club. Fantastic. So that's kind of reverse psychology in a way. And another idea from the green hat, join online groups and meet online and then arrange to meet in person. So take this kind of social media ability that is more easy now and then arrange to meet in person once you've recruited from there. Fantastic. And the orange hat is saying, join a club or activity where I'll meet people with similar interests. Because of course, they will be there waiting for me. Yes. And of course, there will be clubs out there that have my particular interests that will be nearby enough for me to join easily and regularly. Absolutely. That's very positive thinking. So do we have any other hats? So there's more here from green hats. Attend events I would normally never attend. Yes. So a little bit in the vein of doing something unusual. See if I can change myself and my sphere in life to take in something new. Then we've got a black hat thought here. Have you decided How to see if a friend is genuine. So this is excellent. What is a friend really? How would you know? What are the critical criteria that friendship needs to meet? Very good thinking from the black hat. What am I really defining as a friend? To see if anything else comes in from any of you about the other hat colors. Travel to different parts of the city and try new things. Yes, more things from the creative hat. You're really on a roll here. So go to new places, try new things. That's a very good example of lateral thinking as well. Go sideways in comparison to where you normally are. So let's just see if anything else comes in from the neutral, managerial, or intuitive hats, and then we'll move on to the next thing. Volunteer as well, absolutely. So if you volunteer and you give of yourself, you might be able to show some of the best of yourself, not expecting anything in return. And from there, good things might come your way. And white, how much time do you need to spend with someone to quantify a friend? Absolutely. So there was actually a study done on that recently, which I really enjoyed reading. Apparently it's 70 hours that we need to spend with somebody in order for there to be a feeling of mutual friendship growing. So if you go on a few long walks with somebody and then go around to their house enough times and spend some hours, you might be getting towards that 70 hours. Somebody who's identified, we're getting there, yes, friends in my life. Inviting all the people who live in a house with the same number to a tea party. I love it. So go around and find all the number 17s or something and have a 17 tea party. Love it. Very, very nice. Good. Okay. So we're going to move on from this, although this is a lot of fun. Start a book club. Somebody has said that as well. Yes. So find books that you like. I like how you're using lateral thinking for this. Start with what already interests you and then build from there. Or be different. Obviously, what you're doing in your life hasn't quite worked. So try different things, different places. Wonderful. Interesting that nobody has chosen the managerial, the intuitive hat here, but that's quite all right. We're just going with what is in the flow here. So let's just see if anything else comes in, and then we are ready for the surprise for the end of this presentation. So somebody did have intuitive. Somebody's saying you can't be intuitive on a computer. Challenge your beliefs. So somebody had intuitive, but not a real person. Yeah. Okay. So if there's anything else that should come to you, I will take that on board as well. But I'm going to move us on to the key point now from this part of exercising creativity. Someone said, buy a robot. Maybe that's where we're heading. The test of artificial intelligence, of course, being Turing's test, where can artificial intelligence pass for a real person in an interaction? So once that test is passed, it may be that there can be robotic friendships. That would, of course, be sad. We would be missing out on all that embodied cognition that we get, good feelings when we're with people. I read a very interesting study a little while ago that said we have a totally different release of hormones in our body, oxytocin, in fact, when we are with somebody in person, when we're hearing their voice, that has similar levels of oxytocin release, as opposed to when we are texting or emailing with them. That's a very low level oxytocin. You need a real voice and you need a presence. One of those two is the way that we have an experience of bonding and being happy through the contact of another, instead of just firing off a computer message. As somebody said, you can't be intuitive by computer. Perhaps you can't also have the full benefit of relationship via computer. So the key point really here is that creative thinking can be divergent. Remember the paperclip in the barrel. It can be lateral. You can use a word to inspire you and travel the nerds in your brain. It can be parallel by dividing up the voices. And there are many other approaches that you can use. I have a little list of books to recommend to you at the end if you're interested in the theory of creativity and how to teach these things. Essentially, the key thing is that you find or indeed create a technique that works for you. George Bernard Shaw said, you see things and you say, why? But I dream things that never were, and I say, why not? So that's about not inhibiting yourself. For example, if you're brainstorming, let it all come out. And then afterwards, you can use your analytical thinking to say, is that okay? Will the landlord allow me to paint my window, or whatever it is that you're working on? So we now come to the final part, which is the little surprise, which is the creativity of neuroscience. So just notice my play on words. We're in a presentation about neuroscience of creativity, and here we have the creativity of neuroscience. So every year there are competitions for people involved with neuroscience to create artwork. And I've chosen a few to share with you. So I'm just going to remove the picture of me on the screen so that you can enjoy these. So here is a piece of computerized work, digital artwork by Andrea Caroline Lorwald. And just notice if you can see what it is that is interesting about this piece of artwork. So when you get it, just type in the chat room what you notice that makes this interesting. Right, there is a walnut instead of a brain. So, of course, were it just a normal CT scan, we would say, well, is that art? Maybe, maybe not. But the fact that it is, in fact, a walnut, as the group of peers, we can say, oh, that's interesting. It's a new spin on something. This person has associated two ideas, and we enjoy that, right? So it's quite funny. Okay, so here comes the next one. This is Simon Drouin, who went with the idea of, instead of the brain having to be shown on CT scans, MRIs, etc., why don't we project it on the outside of the head? So he projected the brain on the outside of his skull, so we can see in relationship to his actual external biology and face morphology where the different parts of the brain are, which is really interesting. So as you look down his nose, you're seeing there the parts of the brainstem seen from the front of the head. And you're seeing here parts of the cerebellum that are at the back of the head. So if his head were invisible or transparent, you would see those things coming through. So we think this looks like a watermelon, using the nerd connections in your brain there of what those colors are evoking for you. Excellent bit of associative thinking. So he said, why don't we project on the outside what is inside instead of using mechanisms to show what is inside? Here's another one by Celius Kvikinus. I think she's Scandinavian. That looks like a Norwegian name to me. So what she's done is depicted the brain as though it were a plant. The brain stem is quite literally some kind of trunk of a plant or tree growing. The peripheral nervous system is shown as the roots of the tree splitting off. That would be all of the information going to and from the brain, making us able to move our hands and making us able to sense things in the body. She's then shown the frontal cortex there as a sort of leaf. Right there in the middle of the brain, that might be the thalamus there that she's chosen to show as some kind of fruit, or is that an avocado? I'm not quite sure. The cerebellum is down there as this particular kind of foliage. It's very nice. So she has associated organic structure quite literally with a representation of the brain. And then I have for you one final piece of art here, which is from a creator who has a PhD in neuroscience, but is also an artist. It's a chap called Greg Dunn, and the work is called Self-Reflected. So I'll play this.
The brain is awesome. There's nothing else in the entire universe which makes you you more so than your brain. Every single one of your brains at this very moment is exploding with activity.
Greg Dunn and Brian Edwards wanted to figure out a way to show the brain in all its beautiful complexity, to show your brain itself.
This is really meant to be one of those pieces that just allows the most jaded neuroscientist to step back from the grind at the lab bench and just take a second and say, wow.
4 years ago, Greg and I invented reflective microetching in order to realize this vision. Microetchings allow us to visualize brain activity by reflecting light off millions of tiny etches engraved in a golden surface.
Self-Reflected is not an image or a video taken from a brain scan, but it's a handmade and engineered work of art made from scratch.
We mathematically connected these hand-painted neurons into a giant network and then used a computer to figure out how information would travel through this web. The result is like a flock of birds. Each bird is individual, but they fly together.
When the white light is moving, the best place to stand is in the sweet spot, about 12 feet away from the piece in the very center. Notice some of the neural activity responsible for things such as watching how your brain sees the world, reaching out to pet your cat, waltzing across a dance floor. Try to focus on a single neuron as you pass, and notice that your brain is constantly changing. This is what consciousness looks like. Your self reflected.
So we are coming towards the end now of the presentation, and I have just two more things for you. The first one is this slide here that shows you the books that a lot of the information was gathered from to associatively create this seminar for you today. Edward de Bono's How to Have Creative Ideas has a lot of exercises in it to do with lateral thinking, parallel thinking, lots of other approaches to generate ideas. Mihaly Csikszentmihalyi's book Creativity talks about the traits of creative people according to his analysis of conversations with them. And the Neuroscience of Creativity contains information about the neurodegenerative diseases. The story that I read to you about Amy and her curtain paint came out of there. Lots of other interesting things to do with creativity arising from the brain in a biological way. So thank you very much for your attention and participation today. I'm glad that you loved the artworks at the end. Albert Einstein said, creativity is contagious, so do pass it on. Enjoy the ideas that we've learned today. Create your own things. And if you're hungry for more neuroscience and you're enjoying these presentations, I'm going to be doing a final one in this series of seminars on neuroscience, and in September, it's going to be on the 14th of September, and it's called Neuroscience and Gender Identity. We're going to be looking at how our experience and expression of gender arise in the brain, how that matures through development, what the difference is between sex and gender, whether there is such a thing as a male and female brain, and whether androgyny is really about making a woman manly or a man effeminate, and many other things in between. So I'm really looking forward to that one. So thank you very much for your attention.